concept. Okay, this is the main topic in core Python. This is the core Python main topic, functions. Okay, okay. Already we'll discussing Python supporting both procedure oriented and object oriented programming concept. Okay, in procedure oriented, functions is the main topic. First, we need to understanding what is function. What is a function? A function is a block of a function is a block of organized comma reusable code to perform a particular action or task. Next, observing very clearly, functions can be categorized into two types of functions. Built-in or predefined functions. Second one is user-defined functions. Built-in or predefined functions, user-defined functions. Okay, what is the meaning itself? Built-in or predefined? These functions already predefined for some special purpose. We can use that functions only for that particular purpose. Already provided by the language itself. Already provided by the language itself. Already provided by the language. Okay. Already provided by the language itself. Okay, already provided by the language itself. Already provided by the language itself. That functions we are calling as a built-in or predefined function. These functions are already predefined. Okay, these functions are already provided by the language itself. Okay, these functions are already predefined for some special purpose. We can use that functions only for that particular action or only for that particular purpose. Okay, a function is a block of organized comma reusable code to perform a particular action or task. Here, two types of functions are there, built-in functions and user-defined functions. Built-in functions means these functions are already predefined for some special purpose. We can use that functions only for that particular purpose. These functions are already provided by the language itself. Already we're discussing so many built-in functions, like as a print function to print the result to the output console. Next one, type function we'll discussing to get the type of an object, and the id function we are already discussing to get the address of an object. Next one, coming to number system conversion, bin function, argt function, X function, these functions are already we'll discussing to convert any number system into binary number system, and we can convert any number system into octal number system, and we can convert any number system into hexadecimal number system. Next one, type conversions, like as a int, float, float, boolean, complex, complex, str, list, tuple, set, frozen set, dictionary. Okay, these are the type conversions. We are converting one type of data into another type of data. These are the number system conversions. We are converting one number system into another number system. These are the utility functions, like as a print function, type function, and id function. And we are discussing about help function to get the documentation string of any function, or to display what are the methods are available of any class with the syntax and description. Next one, dir function to get the only method names, to get the only method names. Next one, some aggregate functions we'll discussing, like as a length function, sum function, min function, max function, sorted function, reversed function, reversed function, eval function. We can read the data from the user input, input function, eval function. Okay, these are the mathematical operations: length function, aggregate function, sum function, min function, max function, sorted. Okay, to find the number of elements in a given iterable object, to print the sum of the given iterable object elements, to find the minimum value from the given iterable object, to find the maximum value from the given iterable object, to print the elements in ascending order, and to print the elements in reverse order, to read the data from the user input, and I want to read the data from the user input at any type simply by using eval function. Okay, different functions already we'll discuss it. Now I want to show what are built-in functions are available. What are built-in functions are available. Now simply observing very clearly, Python provides one built-in module. That module name is called built-ins module. First we need to import that module. First we need to import that module. Import built-ins dir of built-ins. Okay, here this is a module. Module contains classes and functions. These are all classes. Okay, next one, these are all built-in functions. Okay, these are all built-in functions. These are all built-in functions. Okay, now simply observing very clearly how to identify this is a class and this is a function. Observing very clearly in Python scenario, as a professionally, class always starts with the capital case, camel case syntax we are following. That a class name having multiple words, each and every word first character is uppercase. C and R and E. Only one word is there at the time first character is uppercase. These are all classes and these are the built-in attributes. These are the built-in attributes, like as a build classes, debug, doc. Okay, any name, both the prefix and suffix, double underscore, that is an attribute. Okay, loader, name, package, okay, specification. And the functions always to follow the snake case syntax. That means lowercase syntax, lowercase alphabets, and multiple words are there. We are using underscore symbol. Okay, these are the built-in functions. Now I want to require what are the built-in functions are there. That built-in functions I want to print. That built-in functions I want to print. Simply here observing very clearly, import built-ins for I in dir of built-ins. Dir of built-ins means it will show list of values. I want to take one by one value from this one. This entire value will be represented as a one string. Now that string contains only alphabets or not. Only alphabets or not. If I dot is alpha. If it is contains only alphabets, now it will starts with it contains lowercase alphabets or not. If I dot is lower. Okay, now simply x dot append of x dot append of I. We are adding that value to the x. X is a list. How to add the element into the list by using append method. Append method. In the list class, one method is there that is called append method. Now simply observing very clearly, these are the built-in functions. How many built-in functions are there? I want to count that one. Simply, we are applying length function. Print of length of x. Length of x. Okay. These are the totally built-in 75 functions are there. In these 75 functions, already we'll discussing in our previous classes, these are all functions. Now we'll discussing about another function. Later I'm explaining. Now we'll discussing about what is meant by second category user defined functions. 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 Observing very clearly created by the programmer. These functions are created by the programmer. Here, these functions are already provided by the language itself, but these functions are created by the programmer. Okay, we can create a function to perform a particular action according to our business requirements. Okay, the type of functions are called user defined functions. How to create a user defined functions? We are follow one syntax. Okay, in Python, one keyword is available that is called def keyword, def function name. Function name, it takes parameters, parameter one, parameter two, up to so on, n number of parameters. Okay, these parameters are optional, not a mandatory. And this is the docstring. Docstring means in that function which logic we are implemented, that logic related user friendly message we are writing. That is also not a mandatory. That is also optional. And we are writing the statement. Statement one, statement two, up to so on. Statement n. Statement n. And the return statement is there, a return value. In Python, this return statement is an optional and the return value is also optional and these parameters are also optional and this is a document string that is also optional. We are defining any function, at least one statement is required. At least one statement is required. This is the syntax to create a user defined functions. User defined function. These functions are created by the programmer. These functions are created by the programmer. Okay, are you clear? Now simply observing very clearly here, just I am creating one function. Print I and def wishes. Print Next one, print by state. Okay. Observing very clearly. Now I am trying to executing this program. Our program successfully executed. Our program successfully executed, but function is not executed. But function is not executed. Function is not executed. Observing very clearly. What will happen here? Okay, first statement is executed. Now control will go to this one. This is a which statement? Function definition. Whenever control reach the function definition, then immediately control will go to outside the function body. Outside the function body. That means control will go to here. This one is executed. Okay, function is not executed automatically. Function is not executed automatically. Whenever we are calling a function, whenever we are calling a function, then only function logic will be executed. Then only function logic will be executed. Okay, but how to call a function? How to call a function? We can call the function. We can call the function directly by using function name. How to call the function? Directly by calling function name. Now simply function name, we need to specify argument 1, argument 2, up to so on, argument n. This is called function calling statement. In that function calling, we are passing some values that is called arguments. These arguments are also optional. Okay, without arguments also we are calling a function. Okay, now simply I want to call this function. Simply we are calling this one. This is a observing very clearly. This is called function definition, function definition, and this is called function calling, and this is called function body. This is called function body. Okay, function body. Whenever we are calling a function, then only function logic is executed. Then only function logic is executed. Then only function logic is executed. Now I am trying to executing this program. Our code is executed to print our function logic. Our function logic. Are you clear this logic? Just this is a sample how to create a function simply by using def keyword. In Python, if you want to create a function simply by using def keyword. Are you clear? In Python, at the time of creating a functions, parameters are not a mandatory, depends upon your requirement. This is an example without parameters. Next one, I am creating another function def add of x comma y addition of x and y. That means it will return x plus y value. It will return x plus y value. Now z equal to x plus y, print of z, print of z. Now I am simply calling add function. We need to specify the parameter values. Now simply this is another example. This is another example to create a function with the parameters. Create a function with the parameters. These are the parameters and these are called arguments. The first argument is passing to first parameter and the second argument is passing to second parameter. This is an example to create a function without any parameter. And this is an example to create a function with parameters, with parameters. Are you clear?
Right.
Yeah. Now simply I am trying to executing this function. I am trying to executing this function. Now result we are getting. Okay, now simply observing very clearly, these are called parameters and these are called argument. Actually, in Python, different type of arguments are there, like as a default arguments, non-default arguments, keyword arguments, non-keyword arguments, non-keyword arguments. Next one, arbitrary argument, variable keyword argument. Different type of arguments are there. Types of arguments, types of arguments. Simply observing very clearly, normal arguments based on function definition or function declaration, non-default arguments are parameters, default arguments are parameters. Next one, based on function function calling. Again, we'll discussing about keyword arguments, non-keyword arguments, non-keyword arguments, and the keyword arguments, keyword arguments. Next one, arbitrary arguments, and the variable variable keyword arguments. Simply we are calling as a KW args, KW args, variable KW args. These are the different type of arguments. In future, we'll discussing about these arguments with some different examples we are explaining. Okay, these are the different type of arguments. Next one, why we are using functions? Why do you need functions? Why do we need functions? Functions. Okay, observing very clearly reusability. Functions are providing reusability of code. Functions providing reusability of code. Reuse code, reusability. That means write once, write once, use many times, use many times, use many times. Second one, reduce the repetition, reduce the repetition, 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 reduce the repetition. Avoid writing the same code again. Avoid writing the same code again. Next one, make a program organized. That means divide a large program into smaller tasks. Make a program. Okay, make the program organized. Organized. What is that means? Divide a large program. Divide a large program into smaller task. Smaller task. Make a programs organized. Make a programs organized. Next one, improve the readability. improve the readability, improve the readability. What is that means? Observing very clearly, function names can clearly describe what the code does. Function names can clearly can clearly explain, describe the what code we are writing or what code does. Okay, these are the functions. Why do we need functions? Reuse code. Write once, we can use that code many times, reduce the repetition to avoid the writing the same code again and again. Make the programs organized. Divide a large program into smaller tasks. Improve the readability. Improve the readability. That means function names can clearly describe the what code does. Now simply observing very clearly, we'll discussing different for suppose in Python, if you want to print anything, simply by using print function. Next one, I am declaring x equal to 10. I want to print x. I want to find the type of x. I want to print address of x and y equal to 10. I want to convert this value into binary. Print of bin of y. I want to converting this value to oct of y, and the print of I want to converting this value into hexadecimal by using x function. Next one, a equal to 5372. I want to print number of elements in my list by calling length function. I want to find the sum of my list object elements. Simply sum function we are calling sum of a. I want to find the minimum value min of a. I want to find the maximum value max of a. Next one, I want to print the elements in ascending order sorted of a. I want to print the elements in descending order sorted of a comma reverse equal to true. Next one, I want to print the list object elements in reverse order. Print of list of reversed of x or a. Okay, these are the built-in functions. Okay, these functions are already predefined. Okay, ascending order, descending order, and reverse order. Okay, the statement is executed, just hi message is printed. This statement is executed, 10 is printed. This statement is executed, int, that is an integer. This statement is an executed, it gives some address. This object where it is created in our memory, that address, binary. Binary representation 0b 1010 octal octal value. Okay, we are converting this decimal to octal. Octal value simply here we'll get which one 0012. Octal is represented for octal 0012 and 10. 10 is represented for in the hexadecimal representation 0x a. A is for 10. Next length of a, it gives the element 4. Sum of a, it gives sum of these element 5 plus 3 8, 8 plus 7 15, 15 plus 2 17. Next minimum value is 2 and the maximum value 7 is printed. Sorted by default it gives ascending order 2 3 5 7. And coming to here descending order 7, 5, 3, 2, and the reverse order 2, 7, 3, 5. 2, 7, 3, 5. This is the result. This is the result. Are you clear? These are the built-in functions already we'll discussing. Okay, user-defined functions means we are creating a function according to our business requirements. Next one, in functions, we'll discussing about function recursion. What is the meaning of function recursion? Function recursion means a function can call itself. Function recursion. Function recursion. What is the meaning of function recursion? A function, a function can call itself. Itself. A function can call itself. That is nothing but a function recursion. Function recursion. Basically, in the function recursion, two types of function recursions are there, like as a finite recursion and infinite recursion. Infinite recursion. Infinite recursion. Finite recursion and infinite recursion. Finite recursion means a function can call itself. Okay, at any point of time, the function recursion will be stopped. The function recursion will be stopped. For suppose I want to find the factorial of the any number. First one, I want to take the number as a input from the user. How to take the input from the user? Simply by using input function. But I want to take the integer as a input. Simply we are applying the into function. You enter your number. That is not a mandate. That is just one message. Enter your number. Enter your number. Enter your number. Next one, I am declaring one function def fact of x. If x double equal to 0, 0 factorial means 1. Else block, it will return x into, again we are calling same function itself. Now simply result equal to fact of number. Now simply print off the factorial of number is, I want to display the result here. I want to display the result here. This is an example for function recursion. This is an example for function recursion. Here I am creating my own function, fact function. Yeah, please try to understanding this logic. Okay. A function can call itself is nothing but a function recursion. Function recursion. Okay. Same code we are implemented by using built-in models. Python providing some any number of built-in models, observing very clearly here num equal to. Before that one, we are importing one model.
Sorry, Krishna. One
Yeah, tell
second. Um, so that factorial calculation of 5 into 4 into 3 into 2, like that,
yeah,
right?
yeah.
The else statement return x into, I mean, 5, you can enter 5
No, no,
into.
no, no, no. Here, observing very clearly, here I'm passing the number 5.
Yeah.
That is my input 5. Now simply number is also 5. Fact function is calling x value 5. 5 double equal to 0. Condition fail. Now condition fail here. Automatically control will go to else block. Return statement means it will don't return immediately. Once function is over, then only that return value is printed. That is the main purpose of return statement, to hold the function result. Okay, in previous classes we'll discussing, that means in the next classes we'll discussing what is the return statement, everything. Just this is a overview. Okay. Now simply return statement here. 5 into again fact of 5 minus 1. Again fact function is calling. Now x value is 4. Again this condition is failed. Again this condition is failed. Control go to else block. Already return statement having this one. Again which one? 4 into fact minus, that means 4 minus 1. Again this one. Now again verify this condition. 3 double equal to 0. Condition is false. Condition is false. Again control go to else block. Now current x value is 3 into fact of 3 minus 1. Now simply verify this one. 2 double equal to 0. 2 double equal to 0. Again condition is failed. Now simply control go to here. 2 into fact of 2 minus 1. 2 minus 1. Next again we are verify here. 1 double equal to 0. Okay, condition failed. Control go to else block. 1 into fact minus 1 minus 1. Now x value 0, it will return 1. Already return statement having this one. Now finally return statement here return value 1 means already this calculation is there. What is that one? 5 into 4. Okay, 20, 60, 120 into 1, 120. Now into next, what is the return value? 1. 120 into 1. Are you clear? That is the execution flow. Here we are calling fact function by explicitly only one time, but internally that function can call itself. That is called function recursion. Are you clear?
Yeah.
Yeah. Same logic we are implemented. Same logic we are implemented by using one built-in model. Python providing one built-in model that is called math model. We need to import. We need to import. We need to import factorial. That is a one already function is that is a Python advantage. In Python, everything modules are there. Num equal to int of input of enter your number, enter your number, enter your number. Now simply result equal to factorial of our number. Now simply print of f string the factorial of number is that result. Okay. This is the simple Python code by using built-in factorial function from the math model. From the math model. In Python, everything modules are available. Just we are importing, and this is our user-defined function. We are creating your own logic, but same logic is already existed in the factorial function from the math model. Are you clear?
Yeah.
This is about a function recursion. Infinite recursion means the function recursion continuously calling, continuously calling. Next one in the functions, one more important concept that is called anonymous functions. Anonymous functions. Some people we are calling as a lambda functions. Lambda functions. Anonymous functions are lambda functions. Anonymous functions are all lambda functions. Anonymous functions are lambda functions. Okay, we can define a function without a function name. We can define a function without a function name, without a function name. That type of functions are called anonymous functions or lambda functions. These functions are called nameless functions. In Python, if we want to create a nameless function simply by using lambda keyword. If you want to create a normal function, If we want to create a normal function by using def keyword, def function name, parameter 1, parameter 2, up to so on, n number of parameters. Statement 1, statement n, statement n number of statements we are writing. This is a normal function syntax. Normal function syntax. Next one, if we want to create a anonymous function by using lambda keyword. Because of that reason, some people we are calling as a anonymous functions are also called lambda functions. Lambda arguments, arguments under expression. This is called single line functions. Okay, single line functions are also. Okay, simply observing very clearly. I want to create a normal function. I want to create a normal function. I want to create a normal function to check whether given number is either even or odd. Simply take the number, int of input of, enter your number, enter your number, enter your number. Now simply observing very clearly, here I am declaring even or odd of x if x mod 2 double equal to 0, it will return or return which one even number. Otherwise, control will go to else block. It will return odd number. It will return odd number, odd number. Now simply I want to call that function even underscore odd of number we are passing. Observing very clearly, I'm passing 5. That is an odd number. Now I am passing number 8. That is an even number. That is a even number. Next one, observing very clearly, same program we are implemented by using lambda function concept or anonymous function. Okay. Now simply observing very clearly, here I am using one variable. Here I am assigning lambda expression. I am assigning lambda expression, lambda argument x. If x mod 2 double equal to 0, I want to print even number. Otherwise, control go to else block. I want to print odd number. Now simply print off even or odd. Okay. Previously, totally 5 lines of code we are writing. In place of 5 lines, we are writing single line of code. Okay. Same result we are getting. This is a normal function and this is a anonymous function syntax logic. Here 5 lines of code we are writing, but here only 1 line of code we are writing. Okay. The lambda keyword is used to create a anonymous functions or nameless functions or single line functions. Is used to the lambda keyword the lambda keyword is used to create a anonymous functions, anonymous functions or Some people you are calling as a nameless functions. Nameless functions. Okay. Next one, single line functions. Single line functions. Single line functions. The lambda keyword is used to create a single line functions. Next one, the lambda functions are used in higher order function. The lambda keyword is used in higher order, higher order functions like filter, map, reduce, reduce. These are the higher order functions. These are the higher order function. Higher order means a function takes the parameter as a another function. A function takes the parameter as a another function. Okay, in future classes, we'll discussing about these functions concept. Next one, observing very clearly variables. We can define a variable at the beginning of the program or above the function definition. That variable we are calling as a global variable. We can access anywhere in our program. We can access anywhere in our program. Here I'm declaring one function. Here I'm declaring one variable. This variable act as a local variable to F1. F1. Here I am declaring another function, a function inside another function also possible. At that time, this variable act as a non-local to which function? F2 function. Next one, here I am declaring one more variable. Now this variable act as a local variable to F2. This is a non-local variable. Okay, observing very clearly. In procedure oriented functional programming, three types of variables are there: global variable, local variable, and non-local variable. Now simply observing very clearly, local variable to here z is a local variable to f2. That means within the function f2 only we can access. Within the function f2 only we can access. We can access. Outside the F2, we cannot access Z. Z is a local variable to function F2. Within that function only we can access. Next one, Y is a which variable? Local variable to F1. That means within the F1 we can access Y. And outside the F1 we cannot access Y also. We can access only X. X is a global variable. We can access anywhere. We are executing this program. First, this statement is executed to allocate the memory for global variable. Next, control will go to here. This is a function F1 definition. It is not executed. Control will go to outside the function definition F1 directly. Control will go to here. This is a which statement? F1 calling statement. Now F1 body logic execution is started. Now to allocate the memory for Y, control will go to this one. This is a function definition F2, but it is not executed immediately. Control will go to outside the function definition F2. Outside the function definition F2, this is the F2 calling. Now F2 body logic execution is started to allocate the memory for Z. Now to print the X value 10, Y value 20, Z value 30. Control will go to, after executing the statement, control will go to here. Now X value 10 is printed, Y value 20. After executing the statement, control will go to here directly. Now here only X we can access. X is a global variable, we can access anywhere. Y is a local variable to function F1. Within the F1, we can access anywhere. And the Z is a local variable to F2. Within the F2, we can access Z variable. These are the three types of variables are there. Are you clear? These are the variables. Okay, this is about functions concept overview. Okay, functions concept overview.